Hello, everyone. So today's topic is trigonometry and right angle triangles. So this is maths assignment 2. So I hope you are enjoying it. I'll go through some basic stuff, some less basic today. So it's a mixture, and I will be covering quite a bit of theory today. So let's start with problem 1. Using the definition of sine, cosine, and tangent, show that these two uh, identities are true. So let's draw a random right angle triangle. Okay, so another one, and this one. Now in a right angle triangle, if we take the angle to be theta, let's say that this angle is theta, then this side is called the opposite side, and side is called adjacent. This is a right angle, and this is the hypotenuse. Now, sine theta, by definition, is equal to the opposite side divided by hypotenuse, of course. And cosine theta is adjacent divided by hypotenuse. And we know that tangent theta is opposite divided by adjacent. Okay. So we can write that sine divided by cosine. So we're trying to prove the first identity. The first identity, so sine theta divided by cos theta is sine theta divided by cos theta, which is opposite divided by hypotenuse divided by adjacent divided by hypotenuse. Now we know that when you divide fractions, of course, this fraction flips. So opposite divided by hypotenuse multiplied by hypotenuse divided by adjacent. And hypotenuse cancels, and we get opposite divided by adjacent, which is obviously tangent theta. So we've just shown that sine theta over cos theta is the same as tan theta. The second identity, well, we know sine squared theta is opposite over hypotenuse. So sine squared theta plus cos squared theta equal to opposite squared divided by hypotenuse squared plus adjacent squared divided by hypotenuse squared, and combining them, hypotenuse squared, opposite squared plus adjacent squared. But opposite squared plus adjacent, it's a right angle triangle. So Pythagoras theorem says that adjacent side squared plus opposite squared is hypotenuse squared, and that's always the case. Therefore, opposite squared plus adjacent squared is simply hypotenuse squared divided by hypotenuse squared, which is 1. So we've shown that sine squared theta plus cos squared theta is just 1. Now, again, if you have questions, you can ask them in the Q&A. So you press more on the bottom or on the top, and you can have a Q&A. Next one, problem 2. And this is a more like a geometric problem. The side of an isosceles triangle is A, and it's very similar to one of the questions in the assignment. So you have an isosceles triangle, Let's draw an isosceles triangle. And the side is A. The angle at the base is theta. So this angle, the base is theta. With these identities, you can use letters by all means. Letters is better. Letters is better. Okay. And okay, so here we want to find the angle, find the heights and base in terms of A and theta. Okay, in terms of A and theta. Lovely. Well, first of all, let's start with finding the height. I'm going to find this, I'm going to draw this height of a triangle. Height is a perpendicular, perpendicular drawn from one of the vertices, and let's call it H1. For this, now considering this triangle, so let's say that this is ABC, and this point is D. So BD is the height. Now consider triangle BCD. So this is a right angle triangle, this is theta, this is H1, and this is A. Now we know that this is opposite and this is hypotenuse. So we know that sine theta is opposite, which is H1, divided by A. You know what? Let's use letters. This is D, C, B. So it's BD over BC, which is H1 over A. And from here, we can express H1, the height, is A multiplied by sine theta. And that's the first answer. Yes, we found the height in terms of A and theta, A sine theta. Now, to find the base, AC is the base. AC is the base. And we know that DC is half of AC. So to find DC, well, we can write that DC over BC is equal to cosine of theta. It's the adjacent divided by hypotenuse. And therefore DC, which is we're looking for, DC over A is equal to cos theta. So DC is equal to A multiplied by cos theta. Now the base is AC, so AC is 2 times DC, it's double DC, which is 2A cos theta. So that's the base. And that's the second answer. And what else do we need? Oh, we need the other height. What is the other height? Well, the other height is AE. If we draw AE, that is also known as a height of a triangle. And to find this, we will consider triangle AEC. So AE is the height of triangle ABC. Consider triangle AEC. And we can draw it like this. AEC, this is 90 degrees, this is theta, this is AEC. And we know that the bottom side, AC, we know that AC is 2A multiplied by cos theta. We know this side. And we know that AE is the second height. AE divided by AC is sine theta because it's the opposite divided by hypotenuse. Opposite divided by hypotenuse. So AE divided by AC. So we know AC. So AE is the height, which is AC multiplied by sine theta. And AC, we know it's 2A cos theta sine theta. And that's the length of the height AE. But can you explain how AE is also the height? Well, if you take this triangle, make a copy, and flip it onto this side, then you can clearly see that AE is the height. Any triangle has three heights, right? Because there's another height, which would be CF, for example. But CF would be the same as AE, so we don't need to find it. Could we assume that isosceles triangle? No, you can't assume that. No, you cannot make such assumptions. Okay. We will be able to see these notes on Canvas. You can always access these notes on the website. So if you go on the website and you go to webinars, on the bottom, there's the year 10 whiteboard, and that's takes you to this board. And I'll post the link in the chat as well. Not the chat. Oh, I'll post it in the chat as well. Why not? Okay. This should be an increase in number of people. Yes, definitely. Now, yeah, I hope that makes sense. How AE is also the height. I hope I answered that question. Explain how to use the trigonometric circle. That's the interesting part, because it obviously makes sense. Like sine 30 degrees. Yes, sine 30 degrees makes perfect sense because you can have a triangle with 30 degrees. But then, because we know sine is opposite over hypotenuse, opposite over hypotenuse. Sine 62 degrees makes sense because you can draw a triangle, a right angle triangle with a 62-degree angle. But then, if I ask you sine 150 degrees, if you type it in the calculator, sine 150, it will tell you that it is 1/2. But you can't have a right angle triangle with a 150-degree angle. That's nonsense, right? So how can you have a sine for an angle which is more than 90 degrees? Because a right angle triangle cannot have an angle more than 90 degrees. And yet, if you type in sine of any angle, sine 598, it also gives you some kind of value. So what's it all about? And this is where we come to the trigonometric circle. A trigonometric circle you might be right. Doesn't AE equal tan theta over A? Well, no, because this would be EC, and EC is not A. Tan theta is AE divided by EC. So AE is EC times tan theta, but EC is not A. And besides, it can't be divided by A because then you have a wrong units. So short answer, no. Are we allowed to use calculation assignment if it's not stated we can't? You yes, yeah. It's not a problem to use a calculation assignment. No, of course not. You can't real in some questions you can't rely on the calculator. You can't just say, "Oh, it's that because my calculator said so." Because calculators are increasingly clever, but yeah, by all means use a calculator if it's helpful. Okay, so going back to the trig circle. A trigonometric circle is a circle of radius 1 placed at the origin, at the center of a coordinate system. So let me take a circle. Okay. Now, if we take a random point on the circle with coordinates x, y, the radius of the circle is 1. So this is 1, this is 1, this is -1, and this is -1. If we take a random point on the circle and we draw a line from the origin to that line, then of course this line is 1. This length of this side is 1. And if you draw a right angle triangle and then label this angle as theta, then this side is going to be y because the coordinate of this point is xy. So this length of this side of the triangle is y. And the length of the side of this triangle is x because the coordinate is x. And this is 0. Yes, so right. Now considering this triangle, we can write that sine theta is the opposite divided by hypotenuse, which is y divided by 1, which is just simply y. And cos theta is adjacent divided by hypotenuse, which is simply x over 1, which is just x. So in other words, the coordinates of this point are cos theta and sine theta. Theta is the angle. I don't know what it's just typed. Yes. Ooh, yes. So the theta is the angle from the x-axis, always counted from the positive x-axis, counterclockwise. Theta always calculated anticlockwise from positive x-axis. That's important. So the coordinates of the point are cos theta and sine theta. So if you know this angle, then the coordinates of that point, let's see how that works in real life. Well, I wouldn't call it real life. It's GeoGebra. Now you take A and B. This is a unit circle. Now we take a ray. We draw a ray from A to point C, where C is a random point. And go in settings, name and value. Oh. Oh, of course. Okay. Oh, now I just need to move. Oh, I don't know what that is. C. Okay. So point C can move, and as I move it, it changes the values. Now, if I measure this angle, I can find sine and cosine of any angle. Look, if I take this, what this picture tells me that cosine of 29.2692 degrees is 0.8723, and sine of 29.2692 degrees is 0.4889. Pretty cool if you think about it. Pretty cool. And all you need is just to put some known points. So for example, if this is 0 degrees, then cosine is 1 and sine is 0. If it's 90 degrees, cosine is 0 and sine is 1. Oh, it's a rounding error. Oh yes, 0 and 1. If it's 140 degrees, like this, and so on. Okay. It doesn't allow me to do more than 180, but you can imagine more than 180 degrees. So I'll just do an example. So this is not 149. So this is not 149. This is 360 minus 149. 360 minus 149.5076, which is 210.49 degrees. And what this means is that cosine of 210.49 degrees is minus 0.8617, and sine of 210.49 degrees is minus 0.5074, which is quite interesting. So let's check it. Sine 210.49, and here it is. It's minus 5074. Okay, nice. What was the question? Is theta always this? Yeah. So we can say the top of the y-axis is 90 degrees. Yes, absolutely. So let's take this here, and you know what we can. Oh, we can draw this, and we can put some values. So this is 0 degrees. Like this is 0 degrees. This is 90 degrees. This is 180 degrees. This is 270 degrees. And this is 360 degrees. So 360 degrees is the same as 0 degrees. Now, if I draw 30 degrees, 30 degrees. This is 45 degrees. And this is 60 degrees. Nope. 60 degrees. And this is 45 degrees. Now, the coordinates of this point is 1, 0. The coordinate of this point is square root of 3 over 2 and 1/2. The coordinates of this point is square root of 2 over 2, square root of 2 over 2. And this point is 1/2 and square root of 3 over 2. And this point is 0, 1. And from this circle, we can work out sine and cosine of any of these angles. So for example, cosine 30 degrees would be square root of 3 over 2. Cosine 45 degrees is square root of 2 over 2. Sine 60 degrees is the y coordinate, so it's square root of 3 over 2, etc. That's how you can use it. Of course, there's many more uses. This is just maths today. Can you use trigonometric circle if you don't know theta? Well, yes, in some cases, yeah, you can. You can, not straightforward like this, but yes. But now the beautiful thing, if you carry this on and you have a point, so this would be 120 degrees. This would be 135 degrees, and this would be 30 degrees, and the coordinates of these points, they're symmetrical. They're symmetrical to these. So the coordinate of this point would be minus 1/2 square root of 3 over 2. This would be minus square root of 2 over 2 and square root of 2 over 2. And this would be minus square root of 3 over 2 and 1/2. This point is minus 1, 0. And then we can carry on onto the other side. So this is this and this. So this is 150 degrees. What did I say? 150 degrees. So this is 210 degrees. 220. Sorry. 210. Yes, 225 degrees. 240 degrees. And then on the other side, this 315 degrees. This is 300 degrees. And this is 330 degrees. 360 degrees. So, and then you just need the coordinates. And the coordinates, because it's the XY coordinate, right? There's nothing new here in terms of that. If you drop this line here, then you can see that the coordinate of this point is minus square root of 3 over 2 minus 1/2. This is minus square root of 2 over 2 minus square root of 2 over 2. This point is minus 1/2 minus square root of 3 over 2. Now, if you go across this way, now the x will be positive. So this is 1/2 minus square root of 3 over 2. This would be minus plus square root of 2 over 2 minus square root of 2 over 2. And the third point is square root of 3 over 2 minus 1/2. And now using this trig circle, you can find any of these standard angles. And of course, this bottom point is 0, minus 1. So you can find, I don't know, sine sine 330 degrees, which is minus a half, or cos 225 degrees, which is minus square root of 2 over 2. Or you can find a cosine of 270 degrees, which is 0 because the x coordinate is 0. You can find sine 180 is also 0, etc. You could go on. And even then you can even do 390 degrees. If you do cosine 390 degrees, that means you go a whole circle, that's 360, and then another 30. So you end up in this point. So this point is not only 30, but it is also 390 is also here. So it is the square root of 3 over 2. I can talk about this circle for a long time. It's really amazing. You can study it, but just play around. Try making the same thing here and try to uh, angle. Make the angle and then just play around with it. See what you can get of cosine and sine of any angle by just looking at the coordinates, name and value. So just like that. So it's pretty cool. Um, yes, you can visualize sine A plus sine B, definitely. You can definitely use that to help you visualize. Now, problem 4, the tangent axis. The tangent axis is quite interesting. So if you take the trigonometric circle and you draw, so you know that this is one, and you draw a vertical line here, and then if you take this angle theta, now you know that this bottom side is always one, and let's say that this side, the length of this side is well, let's call it uh what do we call it? T. No, let's not call it T. Let's call it just A. Okay. We know that tan theta is opposite over adjacent, opposite over adjacent, which is A divided by 1. So if this is 0, then the vertical coordinate of this point is the tangent. So tangent tan theta is equal to the intercept. Let's see how that works. So we need a vertical line. So we don't need that point for now. We can draw a vertical line. Okay, and intersection. Must be an intersection somewhere here. Okay, let's see if we can do this. E. Let's see if we can move point. Yeah, we can. E. Label, name and value. So the second coordinate is the tangent. So for example, 45 degrees Tangent of 45 degrees is 1. So if this value is theta, then this value is tan theta. This is tan theta, and this is theta. So it's quite interesting as well. So you can find the tan of any angle, like 66 degrees. So tan 66, tax 66.8 should be about 2.34. Let's check if that is the case. Tan 66.88 is 2.34. Okay, a little bit of rounding error, but we got there. Okay, so I hope that makes sense. In a similar way, you can use the cotangent, but that's one of the assignment questions. You need to work out how to do it. Now, the next part is the significance of quadrants. And remember that the x and y, so sine x and y of a point on a circle is the sine theta and cos theta. But if you look at the quadrants, so here x is positive and y is positive in this quadrant. So in this region. In this region, x is negative and y is positive. In this region, x is negative, y is negative. And in this region, x is positive and y is negative. Okay, I hope that makes sense. But x is cosine. Oh, sorry, it's the other way around. It's cosine. X is cos theta and y is sine theta. So for angles in the first quadrant, we say, so any angle between 0 and 90 degrees. So angles, so this is 0 to 90 degrees. So from 0 to 90 degrees, this is from 90 to 180 degrees. We call this quadrant 1. We call this quadrant 2. We call this quadrant 3, which is 180 to 270 degrees. And we call this quadrant 4, where it is 270 to 360 degrees. And now, if you draw a circle, the sine theta is positive in the first quadrant and the second quadrant, and it's negative in the other two. Cosine theta, cos theta, is positive in the right two quadrants, and it's negative in the other two. And tangent theta is sine divided by cos. So in order for sine to be positive, both sine and cos should be positive or negative. They should have the same sign. So here, plus divided by plus is plus. Plus divided by minus is minus. Minus divided by minus is plus. And minus divided by plus is minus. So tan theta looks like this. That means any angle between 0 and 90, sine, cosine, and tan would be the same. And this can be combined into something people call a cast diagram. I'm not a fan of a cast diagram, but maybe you like it. It's called CAST, cast. So A stands for all positive, and C only cos, S only sine, and T only tan. So it's an easy way to remember. I sort of remember that sine is the y-axis and cosine is the x-axis, and then I figure it out from here. So that's the significance of quadrants. So example, if theta is obtuse, obtuse means between 90 and 180. That's what an obtuse angle is. That means cos theta is going to be negative, sine theta is going to be positive, and tan theta is going to be negative. Pretty cool, hopefully. Mhm. Yes, you have access to the recording. The recordings are also on the webinars tab on our website. All COMPOS webinars or all year 10 webinars. All year 10 webinars is just for this year, and all COMPOS webinars is just for all years. Mhm. Right, moving on. And here's an example of how to use it. It is given that now sec, it's something you need to know. Sec theta is just 1 divided by cos theta. Sec theta is minus 6 over 5, and theta is between 180 and 360. So it's either quadrant 3 or quadrant 4. We don't know which one. Find the exact value of tan theta. Now, sec theta is 1 over cos. Now, so 1 over cos theta is minus 6 over 5. That means that cos theta is minus 5 over 6. Right? Now we know that sine squared theta plus cos squared theta is equal to 1. So sine because cosine is negative, that means because cosine is positive, positive, negative, negative. If it's negative, that means it's quadrant 3. So theta is in quadrant 3. All right, sine squared theta plus minus 5/6 squared equals 1. So sine squared theta equals 1 minus 25 over 36, which is 9. Oh, seriously. 9 over 30. What? Doesn't make any sense. It's not 9, it's 11, of course. Of course, it doesn't make any sense. It's 11 over 36. And so sine theta is plus or minus square root of 11 over 6. But we know that it's quadrant 3, and that means that theta is negative. Therefore, sine theta is minus square root of 11 over 6. Now, finally, we know that tan theta, so this is the answer, tan theta is sine theta divided by cos theta, which is minus root 11 over 6 divided by minus 5 over 6, which is plus cancels, 6 cancels, it's root 11 over 5. And that's the answer. Okay, a very similar question. Let Sine x is 2/3, where x is obtuse. Obtuse, that means quadrant 2. So this region, quadrant 2. So we write sine squared x plus cos squared x equals 1. So 2/3 squared plus cos squared x equals 1. Cos squared x equals 1 minus 4/9, which is 5/9. So cos x is plus or minus √5/3. But because it's quadrant 2, therefore cos negative. Quadrant 2, hence cos x is going to be negative. Therefore cos x is equal to, so minus square root of 5/3. And now we can find tangent. Tangent x is sine x divided by cos x, which is 2/3 divided by minus square root of 5/3, which is minus 2 square root of 5, 2 over square root of 5. This can be simplified to negative 2 square roots of 5 to 5. Doesn't look like a simplification, but sort of is. And now we need to calculate sec, cosec, and cotan. So sec x is just 1 divided by cos x. So that's 1 divided by minus square root of 5/3, which is minus 3 over square root of 5. Cosec x is 1 divided by sine x, which is 1 divided by 2/3, which is 3/2. And cotan x is 1 divided by tan x, which is 1 divided by minus 2 square root of 5/5. Well, you know what? I'm not going to do that. I'm just going to use this answer. Minus 2 over √5, which is minus √5/2. Kevin, I assume you mean rationalize the denominator, because you can't rationalize a surd. You can only rationalize the denominator. No, you don't have to. It's you can, but not necessary. It's the last thing we are worried about, if you rationalize or not. Okay. The next graph, the next 3 problems, they're very similar problems, and they deal with the cosine graph. Or the last one is the sine graph, but sine and cosine graph. And you will be asked to draw them. So let's have a look how they look like. So Desmos, and I'm going to draw again degrees, and the x-axis from 400 to 400. Okay. And y equal cos x. So this is the cos x graph. Y-axis from -2 to 2. Okay, that's a more beautiful cosine graph. And if you draw a sine graph, sine x. Ooh, that's an interesting thing. Look, the sine graph is just the cosine graph, but shifted to the right. So they are identical, because if you draw y equals sine x plus a, and you're allowed to change a, let's say from 0 to 360. If you change a, that moves the graph, and at some point they match. So when a is 90, sine x is the same as cosine x. That's an interesting thing. Okay, so let's just um, apologies. Sorry. Um, okay. Now, if you have the sine graph, the sine graph is just the cosine graph which is shifted to the right. In other words, sine x can be written as cos of x plus x minus 90 degrees. And similarly, cos x is the sine graph which is shifted to the right. So sine x plus 90 degrees. So this is quite interesting, and you will see this in the assignment as well. Um, um, Interesting. Oh, not this one. Apologies. Uh, did we never ask you to draw the graphs? Oh no, yes, you don't need to do it. It just says fill in the table. Yeah. Okay. That's absolutely fine. Now look what happens if we take this cosine graph and we start adding numbers to it. So cosine graph, you see it goes from -1 to 1. The minimum value is -1. The maximum value is 1. And it has a period of 360 degrees. Now, if you put a number in front here, like 2, you can see that the amplitude increases. So the number in front is called the amplitude. And 3, if we put a 3 in front of x, the period changes, right? So look, 2, 3, 4, 5, 6, 7, 8. You can see that the period changes if we change the number in front of x. And if we add a number here, plus 3, the whole graph vertically upwards. So, 3 and 4. Okay, so what am I trying to say? That for a cosine graph, so y equals a multiplied by cosine bx plus c. Now the number in front is the amplitude. C is the vertical shift. And this next value is not the period, but it relates to the period. Period is equal to 360 degrees divided by b. So let's see cosine x is sine x plus 90. No, I meant what I meant. Yeah, I don't think I've made a mistake. Sine x is cosine x minus 90. Yes. And cosine x is sine x plus 90. Right. So look at this graph. So you can see that the graph has a vertical shift of 4. Yes, because it's shifted. It was used to be here. Now it's here. So C is 4. Now A is the amplitude, 4 and 6. So the amplitude is this distance, A. And A is 2. And the period is how the length of one complete wave. And we can see that for 360 degrees, this is 360, is 3 complete waves. 1, 2, 3 waves. So period is 120 degrees. So the graph repeats every 120 degrees. That means 360 divided by B is 120. That means B is 3. And then we can write down the equation using this expression. So y is equal to amplitude is 2, cosine b is 3x plus 4. And that's the equation that we had. Indeed, cosine 2 cos 3x plus 4. That's how you do it. So it's quite a straightforward exercise. So let's look at this this graph. So the equation is a cos bx plus d. So a is the amplitude. So we draw the midline, and this is the amplitude, a. So that's 1 to 4, so that's equal to 3. So a is 3. The period, and the period starts from here, and it does a complete cycle in 180. So the period is 180 degrees. And we need to find b. We know that 360 divided by b is the period, 180. So b must be 2. So b is 2. And find the value of d. D is the vertical shift. So it's shift from the middle line. So d is 1. So the equation is f of x is equal to 3 cos 2x plus 1. And if we draw that graph, it would be exactly the same. Amplitude. Amplitude is the distance from the middle line, medium line, to the top. Or you can say it's the difference between the maximum and the minimum. And if you take this value, this is 2 times the amplitude. So if you imagine a swing that goes left and right, the amplitude is the distance from the middle position to the extreme position. So that's what amplitude is. Right. Now this one. Now this is a little bit tricky because it's a flipped. It starts from -2. So the amplitude is 2. Amplitude is 2. The modulus of A is 2. But because it's flipped, it's -2. I won't go into much detail about this. It's just A is -2. Look, if I make x cos x, if I make it -2, It just flips the graph upside down. So +2, -2. +2, -2. The period of f, well, we can see that the period is 180 again, 180 degrees. And the value of b is again, so 360 divided by b is 180. So b is 2 again. So the equation f of x equal a, which is -2 cos 2x. So that's the equation. And yes, you can do the same. Yes, d is just the undisturbed position of the wave. Yes. Thank you. That's a very good way of looking at it. A sine graph can do the same. And here's the sine graph. So part of the sine graph is shown on the diagram below. And we need to find P, Q, and R. So the minimum point is A, 3 minus 1. And B is 9, 5. So we know that the amplitude, so double the amplitude is 5 minus, so 6. So that's 6. So the amplitude is 3. Okay. Now, the undisturbed position is 2. So the vertical shift or the undisturbed position is, or R is 2. The period, now it's asking for the period. Now we start from here, and the full period takes 12 seconds or whatever, 12. The value of Q, we know that 360 divided by Q is equal to, oh, yes, to the period, which is 12. 12 degrees, 12 degrees. And Q must be 360 divided by 12, so that's 30. So Q is 30. Okay. Find the values of P. Now, once again, it's a sine graph, but it's a flipped sine graph. You can see that the sine graph looks like this. And if you put a minus in front, it's like this. So once again, plus, minus is the upside down. So it's going to be -3 because the amplitude is 3. So P is -3. And R is the vertical is 2. R is 2, which we already know. So hopefully that makes sense. The question doesn't mention otherwise, could you start by finding B and then A and C? It doesn't matter which way you find it, whichever way is convenient for you. Okay, problem 8. So this is a problem just to practice practice identities. So these are called identities, and the triple equal sign means an identity. Identity. What does that mean? Well, it means that it is true for all values of theta. True for any theta. So let's if you're just not familiar with identities, example. 3x plus 2 is equal to x plus 1. Can they be equal? Yes, they can be equal, and that is it is 2x only true. So this is only true when x is -1/2. I believe 2x minus 1. Yeah, x is -1/2. So this is an equation. equation. Or if you have 4x plus 6 equal 2x plus 3. Now, this expression is always true. Always true for any value of x. Because whatever x is, this will also always be true because you can open the brackets and you get exactly that. And this is the case where we draw 3 lines. That's what it means. 3 lines means always true. Okay. Do you get more marks for doing the additional questions in the end of the physics paper? Um, normally no. Uh, normally no. Assignment says good to draw the graphs. Yes. Can you please re-explain how you found R? Because I thought. Well, it is the midline. R is the midline is this too. Sorry. This is the midline. Midline. And this is the x-axis. So that's the distance, and that's 2. That's the same. Okay. All right. So we've now we hopefully understand what an identity is, and let's prove some identities. Um, no, that's the amplitude. So we need to prove that for any a, so a cos theta plus sine theta times tan. We know that tan is sine theta divided by cos theta. And okay, we're going to simplify the left-hand side. And this is sine times sine. And we find the common denominator. The common denominator is cos. So we multiply this by cos theta. There's going to be cos squared theta plus sine squared theta divided by cos theta. Cos squared theta plus sine squared theta, we already know that's equal to 1. 1 divided by cos theta. And 1 divided by cos theta, we know it is sec theta. So that is true. B. Cot theta plus tan theta. Cot theta plus tan theta can be written as cos theta over sine theta plus sine theta over cos theta. The common denominator is sine theta cos theta. So we multiply this by cos theta. We multiply this by sine theta. So that's equal to cos squared theta plus sine squared theta divided by sine theta cos theta. Cos squared plus sine squared is 1. So it's 1 divided by sine theta cos theta, which can be written as 1 over sine theta multiplied by 1 over cos theta, which is equal to cosec theta multiplied by sec theta. So true. And then C. C is cosec theta minus sine theta. Now cosec theta is 1 over sine theta minus sine theta. We'll multiply this by sine theta. So 1 minus sine squared theta divided by sine theta. Now, 1 minus sine squared theta. Well, we know that sine squared theta plus cos squared theta is 1. Therefore, 1 minus sine squared theta is cos squared theta. So that's cos squared theta over sine theta, which can be written as cos theta multiplied by cos theta over sine theta, which is cos theta multiplied by cot theta, cotangent theta. Did I used to write cot or cotan? Cot and cotan are the same thing, so cot x is the same thing. Okay, moving on. D. 1 minus cos x, 1 plus sec x. All right, so 1 minus cos x multiplied by 1 plus 1 over cos x. 1 over cos x, so we multiply this by cos x. So 1 minus cos x multiplied by cos x plus 1 over cos x. We multiply these together. This is a difference of two squares. A minus b multiplied by a plus b equal a squared minus b squared. So that's going to be 1 minus cos squared x divided by cos x. 1 minus cos squared x, we already know that's sine squared x over cos x, which is sine x over cos x multiplied by 1 over, oh no, sorry, by sine x. Sine x, which can be written as tan x multiplied by sine x. And I think that's what we needed. Yes, sine x, tan x. Just a moment, sorry. Okay. So 2 to go. And we have E, which is cos x over 1 minus sine x plus 1 minus sine x over cos x. And we multiply this by cos x. We multiply this by 1 minus sine x. So it says cos squared x plus. So on the bottom is 1 minus sine x multiplied by cos x plus. We open these brackets, so we multiply this by that. So it's going to be 1 minus 2 sine x plus sine squared x. Now, we know that cos squared x plus sine squared x is 1. So it's going to be 1 plus, apologies. Sorry. 1 plus 1 minus 2 sine x. 1 minus sine x cos x. And here we can do 2 minus 2 sine x. 1 minus sine x cos x. And we can write 2, 1 minus sine x divided by 1 minus sine x cos x. Okay, and that's equal to divided by cos x, which is 2 sec x. Okay, I really want to do the last one, but I don't think I can manage. I've got whoop, I've got a very needy young mathematician here. Uh, okay, I'll see you all in 2 weeks' time. Sorry for not finishing the last question. Okay, all right. Enjoy the assignment and see you all in 2 weeks' time.